Well, good morning, everybody, and thanks for joining me for another Sprinkler Talk episode. So today is episode 10, and we're looking at sprinkler heads, part 2. So just wanted to start off by reminding you of the sprinkler heads part 1 video that we've already done. So that should be available on our YouTube channel and available on our website. www.projectfire.co.uk. Follow the links to CPD or Sprinkler Talk, and you can find that other video. So in that video, we talked about some of the differences of different sprinkler heads. Just off the top of my head, I mean, there was the temperature difference, there was the finish, whether they're upright or pendant, the approvals, the response time index, the method of activation. So there are lots of differences between different sprinkler heads, and obviously you would choose the sprinkler head that was the best for the application that you were doing. And obviously there are different manufacturers of sprinkler heads as well, and they've all got the slight sort of quirks, I suppose, in terms of how they've been designed, in terms of the actual body of the head and the deflector plate. The deflector plate, of course, is how the droplets are made. So I just wanted to start off by just reminding you about the quick response and the standard response bulbs. So the main difference is the thickness of the bulb. The standard response has an RTI greater than 50, and that is a response time index. Doesn't mean 50 seconds, so that the 50, I forget what the units are now, but it's linked with speed and the sort of the expansion of the liquid, but it's not as simple as saying, oh yeah, it'll activate in 50 seconds, because that's not correct. But the RTI is a measure of the speed, and then quick response has an RTI of less than 50. So yeah, it's a quick response head because it activates more quickly when it comes up to temperature. Okay, so we're gonna kind of leave the presentation here. This is the kind of the exciting bit. So I'm going to stop sharing on this computer, and I'm going to go over to my iPad now. So hold on a sec. So should be able to see my bowl of hot water here. Now I noticed that it's kind of shown in the vertical orientation. I don't think there's much I can do about that, but hopefully it won't spoil the video too much. So I've got a bowl here of hot water, and I'm going to be dunking some sprinkler heads into the into the water, and you can see the reaction. I don't know what the temperature of the water is, but it's hot water, so I'm hoping it's above 68 degrees. Otherwise, it won't work. And it's obviously not hotter than 100 degrees. It is hot water, but it's not boiling water. So what we're going to drop it into here, well, just to make it easy, I've got these two sprinkler heads here. So I've got a quick response on the right hand side, or the top of the video in the grey, and I've got a standard response here, which is a white one. So we're expecting them both to operate because they're both red bulbs, and the temperature of the water is, say, well, fingers crossed, greater than 68 degrees Celsius. But I'm expecting the grey sprinkler bulb to operate first. You can see that these are rapid drop sprinkler heads. So lots of different manufacturers available, but thank you to Rapid Drop for supplying me with a sort of a display case of different bulbs and some samples for these videos and for other things that I do. So here we go. Are you ready? I'm going to pop them into the water and we can see what's going to happen. So here they go into the water. I should say that any reason why they don't activate correctly is no doubt down to my equipment rather than down to the sprinkler heads themselves. And yeah, they don't seem to be doing the business, do they? So yeah, I can assume from that it is the temperature of my water which is not quite hot enough to set off the sprinkler heads. So let's put some heat on, and then we can try again. Whilst we're waiting, I want to show you this kind of plastic clip. So that's generally how sprinkler heads are sort of delivered onto site. They'll be in, when you go to McDonald's and you buy several drinks, they're in sort of a cardboard sort of egg cup sort of shape. That's the sort of thing that the sprinkler heads would be packaged in, and then they'll have this orange clip, which it's just there to protect the bulb. So when the heads are installed, then they'll have this orange plastic clip on, and then so once the handover, the commissioning's in place, then the plastic clip will be removed to reveal the actual bulb underneath. So generally speaking, they are these sort of bright orange design, but different manufacturers are going to have a slightly different design for what the clips look like. So yeah, if you just joined us, I'm going to be setting off some sprinkler heads. Hopefully, the first attempt was a fail. As I say, I'm sure it's not the sprinkler heads that are at fault. It'll be my water. So I'm putting some extra heat into my pan of water. We can probably start to see some steam coming up there. So I'm going to be raising the temperature up. That'll probably do. So let's try again. So I've got my 2 sprinkler heads, I've got my quick response, and I've got my standard response. So expecting the sprinkler head that's in the kind of this grey finish to activate more quickly than the standard response on the left-hand side. Let's have another go. Well, as I say, I practiced it as much as I could, but there's nothing like live TV or live broadcast, is there? Still can't be hot enough. Obviously, I should have invested in a thermometer. Okay, well, say I will turn it up a bit more, get it really hot, and then we can have one more go at getting it to work. Some other things to show you. A concealed sprinkler head. So if you've never seen kind of the inside of a concealed sprinkler head, then here we go. So this one you can see has got the glass bulb installed. You can just see the glass bulb in there, and this is the deflector plate, which is kind of drops down just via these runners here. So it'll be installed like that in the ceiling, and then when the cover plate falls off, then the deflector will drop down, and then the bulb will activate as normal through heat, and then the water will hit our deflector here. And the cover plate looks a bit like this. Again, different manufacturers, different designs, but it's held on by a soldered joint. This one has got sort of 3 parts, and you can see where the solder's been. So yeah, it's in 3 parts, and that just gives it basically a little bit of kind of spring loading, really. When the cover plate detaches, because of this middle section here, it's just going to make it pop and fall away. And obviously that's what we want. We don't want it to sort of gently kind of slide off. We want it to nice fast pop, and that's designed to come away well in advance of the activation temperature of the sprinkler head. So once I've got my sprinkler heads popping, I can show you one of those working as well. I think the problem was there, I didn't want to get the water too hot because I was concerned that the steam from the water would kind of fog up the camera. But like I say, I've obviously underdone the water there. So we're getting it up higher temperature. So we're getting approaching boiling point at the moment with our water. So there is a fair bit of steam coming off. So surely now this will do the trick. So last go, this one's going to work. Got my quick response and my standard response into the water. Whoosh. Quick response is gone. And there goes the standard response. Hooray! So I hope you got a sort of a good view of that. Let's take them out now. So yeah, that worked exactly as planned this time. So there's our quick response. So now you can see that the hole all the way through it. Okay, so the water is going to be coming out through that hole and then hit our deflector. And the K factor of the sprinkler head, which is something that we haven't actually talked about yet, but the K factor is to do with the size of that hole through the middle. So that's quite a large hole. So let's have a look on the top of the sprinkler head. So yeah, I'm not quite sure actually on that one. Some of them have got it marked quite clearly on the top of the heads, which we'll have a look at on the screen over there in a second. The other bits is we've got this two little metal pieces, and obviously some glass as well. Quite tricky to get that out. There. So we've got two other bits to do with the sprinkler head itself. Kind of got this rubberized piece, which is obviously going to help to keep the water from leaking out. So that's how it was. That's how it was in the head, with the bulb obviously in the gap, and then that has come apart to let the water out. Different heads have got sort of different methods of doing that. So here's a slightly different one. This was a Tyco sprinkler head as opposed to Rapid Drop. So it's a slightly different design, but exactly the same principle. And then here's our standard response, which is the same style of head. So yeah, as you would expect, the kind of the way it the bits inside are the same. So I've already kind of proven my point in some ways in terms of the activation temperature. But yeah, this one here is a green bulb. So remember, different colours of bulbs have got different activation temperatures. So this one's a green one. So that is set to operate at 93 degrees. So I'm not expecting this one to operate, but we could duck that one in the water and see what happens. So as I say, that's set at 93 degrees. I'm not quite sure what the temperature of my water is, but I'm thinking it's less than 93. So I'm not expecting that one to operate. Again, we kind of go through this already, but here's kind of one in the flesh. This is a sidewall sprinkler head. These are going to be installed in the wall, and then the water is going to be coming up through here, and then as it kind of discharges here, that's the way it's designed to operate. Different styles. So again, we've already looked at this one. So this is a pendant sprinkler head. So this will always be installed in the upright position. So the water will always come down and hit the deflector. Yeah, did I say that right? It'll always be installed in the pendant position. Yes. So pointing downwards. This one is always going to be installed in the upright position. So it's always going to be pointing up into the ceiling. And again, you can see the different style of the deflector there. Which kind of indicates how it's going to be fitted, which orientation it's going to be used in. See, our green bulb still not operated, which is kind of what I expected to happen. And then ones like this one here, it's marked on the top at CUP. C stands for conventional. Other than spray, and that is to do with the way in which the water is discharged, and then the UP means that it can be installed in the upright or in the pendant position. So this one's like a flexible head. It can be done in both orientations that it will work. So that's quite useful if you're protecting a void area. And the kind of underside of the void in the ceiling, you can use the same head in both places. You're not going to get them kind of mixed up because they'll both work. Take that one out now. That one's done its job, so that one's still intact. So our green head set to operate at 93 degrees. So let's have a look at a concealed sprinkler head now. So I've shown you one that's already been activated. So this one again is typical for how they would be sort of delivered onto site. So again, we have a plastic protective cover, which is there to protect the internals of the head. And we have a kind of sliding mechanism. You can see this one is different. So this is more of a fusible link sprinkler head. So we don't have a glass bulb inside this one, but we have a similar sort of spring-loaded activation. I'm not going to set this one off because I don't actually think you would see anything because everything's sort of inside of the head itself. So yeah, I won't show you that one. So I just had a question, where would you use a 93 degrees head? Yeah, I mean, obviously not very often. Somewhere where the ambient temperature is going to be a lot higher. So it might be some sort of industrial processing place where the ambient temperature may be higher. Remember, they're set to operate at 30 degrees above ambient. So 63 degrees is kind of the highest sort of normal point that we would be expecting. So it might be just a case of skylights, for example. Lots of glass, lots of sunlight. The ambient temperature is going to be higher. But as I say, the red bulbs are by far the most common ones to see. So yeah, just going back to this concealed sprinkler head. So that's it there with the cover plate on, and I'll just show you the cover plate coming away. So I'll just show you how that works. So here's our cover plate. So if I just dunk that in the water, whoosh, and that's come apart. So quite readily. This one's in 3 pieces. Slightly different design to the one I showed you previously. So this has got sort of two main pieces, and then this little bit, the folded metal here, which again is just designed to give it a little bit of spring, just to force the two apart. So when the solder joint is broken, just makes it go ping, rather than sort of slipping and sliding and moving and ahhing about whether it's going to come off or not. Just makes it go ping off. And obviously that's what you want. You want that to come away, well in advance of the head operating. Okay, what else? What else should we do? Or is that about it? Should we set off one more head? Let me get my turn my heat back up, and what I'll do for this last one, I'll just take the camera a bit closer down, so you can have a bit of a closer look at the head being operated. I'm going to go for a quick response. I've got more of those than I do the standard response, so I'm more willing to waste another one of those. So we're going to go for this one here. So this is a CUP head. So this is the one that can be installed in the upright or the pendant position. So I'm putting my heat back on just to be sure. I don't want to be embarrassed again by it not going off. You can see the kind of dye is coming into the water. So my water is now sort of pinkish in colour. Should be fine. Okay, so I'm going to take the iPad off its stand. Risking my iPad here for you. Okay, so yeah, we're going to come in a little bit closer so you can see a little bit more clearly, hopefully. Here we go. Yeah, hope you saw that nice and clearly. I'm sure we can get our tech team to do a sort of a slow-mo view of that. But obviously there's lots of YouTube videos which are going to be showing things very, very similar to that. Obviously in real life it wouldn't be in water, it would just be in the air around. Okay, let's turn off my iPad, and I'm going to go back to my computer now. Okay, just going to make sure you've come with me. Can I hear that? Yeah, good. Okay, so back on the computer. Let's go through just this last slide. Come on, move there. So this slide here is just showing you some of the information that is stamped on the top of a sprinkler head. Again, will vary from manufacturer to manufacturer in terms of how the information is presented, but the information that's there should be pretty consistent across the board. So we have, first of all, number one. So that says pendant. So again, it might just be stamped as P, but this particular one here has it written out in full, pendant. So this sprinkler head here will only be installed in the pendant position. Number two is the kind of manufacturer's mark. So this one here is a VK, which stands for Viking, and it's a 102. So again, ideally, we don't want to kind of mix and match sprinkler heads within a building. We want to, basically just stick with one manufacturer, with one style throughout, really, to keep it consistent. But obviously, different parts of the building may require different sprinkler heads. But say, if it's an office fit out, then the same head would be used throughout. Say both for consistency, but also for aesthetics reasons, it would be better as well. Number three, so you can see there are a few of those. These are the approval markings. So there are four kind of main approvals that you can look out for. I feel anyway. There are others around, but for me, the four big ones are the LPCB, which is the kind of UK-based,
the major UK-based approval agency for sprinkler heads. VDS, which is the one based in Germany. So a lot of the European countries will be adopting sort of VDS as their kind of go-to approval body. And then FM and UL are two that are based in the USA, but obviously have kind of a global influence as well. So this particular sprinkler head has got all 4 of these approvals. Other sprinkler heads may have just 1 approval, or 2, or 3, or 4. So it just depends on the company in terms of what they've submitted to what approval body, and obviously that there's a cost associated with that test, and so it depends which market they want to sell the sprinkler head into. Number 4 is the activation temperature. As I say, the red bulb will give you a good indication of the activating temperature, but it's always good to have it stamped on the head as well, and that's again part of what is required by the approval bodies to have that stamped on the top. So you can see it there. It says 68 degrees Celsius, which is 155 Fahrenheit. And then number 5 is again some sort of code. So this one says SSP. So it's the SS stands for standard spray. So again, we've got standard spray and we've got conventional. So again, the kind of differences between the two are quite subtle. I might talk about that in part 3. It's to do with the way the water is discharged. It's to do with the discharge pattern of the water as it hits the deflector. And then the P obviously stands for pendant. So as I showed you in the kind of live demonstration, the CUP is kind of the alternative, really. That's generally what you see. You either see SSP or you see CUP, or you just see conventional upright CU. So to say, this one is standard spray and pendant. So yeah, it's in the pendant position. So those, again, are just examples of the markings you'll find on a sprinkler head. So yeah, when you're walking around, having, again, if you're like me, having a look at the sprinklers when you're out and about, you can maybe spot some of these things that are stamped on it. Again, this is linking back to the K factors of the sprinkler head. So the K factor is to do with the frictional resistance of the water as it passes through the head. And this is linked into this equation here, Q equals K times the square root of P. So Q is the flow rate in litres per minute, P is the pressure in bar, and the thing that is kind of in the middle is this K factor, which is a constant, which is like, a made-up number, which is there to tie in this frictional resistance into the equation. As you probably know, if you increase the pressure, you will increase the flow. However, it's not as simple as that, because they're going to get a point where it doesn't actually matter how much extra pressure you put in, you're not going to get any more water out. So, like I say, you get this kind of curved line. You can see the example there. And as the pressure increases even further over 12, the graph, the curve will just level off until it becomes a horizontal line, i.e. it doesn't actually matter how much more pressure you put in, you ain't going to get any more flow. But yeah, that's something to bear in mind, is when we talk about sprinkler head K factors, it is to do with the frictional resistance, but in practice, what it means is a larger hole or a smaller hole. The orifice, that the space that the water's got to actually come through the head and hit the deflector. The bigger the K factor, the bigger the hole is in there. And because of the equation, if the pressure is 1, then the flow will equal the K factor, because the square root of 1 is 1, and then Q equals K. So at 1 bar, a K57 sprinkler head will give out 57 litres per minute. So that's quite useful to remember in terms of kind of a quick calculation in terms of, well, how much water, if we've got 4 sprinkler heads operating, well, at 1 bar, it's quite easy to work out. And that's it for this presentation. So I hope you had a laugh with me as my demonstration failed initially, but we got there in the end, didn't we? And I've learned something. I need to make sure that water is a bit hotter than I had it. As I say, I have every faith in sprinkler head design and approvals. I have very little faith in my own equipment and methodology. So if anything went wrong, then I blame myself rather than the sprinkler heads. So thanks again for listening. So next week we're going to be going through residential sprinkler systems. Again, I'll split that up into different parts. Next week will be part 1.